Greetings and salutations, everyone. How are you doing? And how are you doing? Well, that's good. I'm glad everyone's doing well. Okay, today we're going to look at Test 3 Review. Now, Test 3 covers Chapter 4, Chapter 5. So let's go through all of the problems for the review and let's do well on this test, okay? I'm quite sure you will. Hope everyone is staying safe. Hope everyone is well, social distancing, staying at home, and keeping your hands washed and clean, okay? So, I have problems 1 through 5 on the board. You should have the review sheet in front of you. If you don't have it in front of you, pause the tape, pause the video. This is not a tape. Pause the video and get the review sheet so we can go over it together. Okay? Alright, here we go. Number 1. Alright, let's simplify this expression. Please recall that we said the first thing you have to do is multiply. So take this 4, that's the power on the outside, and multiply it times 4 right here. That's going to give me x to the power of 16. Then take this 4 times negative 2. That's going to give me y to the negative 8. We're multiplying, right? Divide it by, take the 4 and multiply it times 3. X to the power of 12. And then 4 times 2. That's y to the power of 8. So far so good? Okay, go next door and do the same thing. Take this 3 and multiply it on the inside. 3 times negative 1. That's going to give me x to the negative 3. 3 times 4. Y 12. 3 times 4 here. That's going to give me x to the power of 12. And then 3 times negative 2. That's going to give me y to the negative 6. Okay, so first we have to multiply. Now we have to do what? Add. Okay? Notice this. I have an x to the 16 and an x to the negative 3. X to the power of 16, x to the power of negative 3. Now you add the exponents. Add 16 plus negative 3. That's going to give me x to the power of 13. Do the same thing for the y's here. Negative 8 plus 12. Y to the 4. Over. Alright. 12 plus 12. X to the 24. X to the power of 24. And then we have 8 plus negative 6. Y to the power of positive 2. Okay? So, what did we do first? First, we multiplied. And right here, then we added. Had to add. Now we're going to subtract. Okay? So I have x to the 13 minus 24. That's going to be x to the power of 13 minus 24. And then y to the power of 4 minus 2. And that's going to equal, well, x to the 13 minus 24 is going to give me x to the minus 11. Because 13 minus 24 is minus or negative 11. And this is going to give me y to the power of 2. Because 4 minus 2 is 2. And what does this equal? Alright, so right here we subtracted. So the last step, or the last thing you have to do in this case, is the rewrite. You have to rewrite it. Why? Because you can't have a negative exponent. No negative exponents. So this right here is x to the negative 11 y squared. And remember now, everything is all over 1, right? So now you take what's negative in the numerator and bring it down to the denominator. That means that this x to the negative 11, that whole thing must now go down to the bottom. So my answer is going to be y squared over x to the 11. And there you have it. That's the answer. And this one's done. That's it. That's how you simplify number 1. Number 2. In this case, we have to multiply. FOIL. 8x cubed times x cubed. In this case, you add the exponents, right? That's going to give me 8x to the 6. Because 3 plus 3 is 6. And then you go 8x cubed times negative 6. Well, 8 times a minus 6 is a minus 48 x cubed. Okay, and then you have to take negative 3 times x cubed. Negative 3 times x cubed, that's going to be a negative 3x cubed. And then negative 3 times negative 6. And that's going to give me a positive 18. All right. Please notice that you have to combine what's in the middle, because they have the same power, x cubed, x cubed. So you have to combine these two terms. These two in the center has to be combined. So what does that mean? That means you bring down the 8x to the power 6. Bring this straight down. Bring down 18. And just combine what's in the center. Alright, now when you combine like terms, please remember you do not add or multiply the exponents at all. It's all about the coefficients, the big numbers. Negative 48 minus 3. What is negative 48 minus 3? That's what you have to know. Negative 48 minus 3. And that's going to give us a minus 51 x cubed. This problem is done. Nothing left to do here. That's it. Number 3. What type of polynomial is this? What's the type? Okay. Is it a monomial? Is it a binomial? Or is it a tri? In other words, is it one term, 2 terms, or 3 terms? Count it and see. 1, 2. There are 2 terms here. So it is a binomial. If it were 1 term, it'd be a monomial. If it's 3 terms, it's a trinomial. If it's 4 terms, polynomial. All right. Good. And those 4-term polynomials are called quartic, by the way. Quartic. All right. Leading coefficient. What's the first thing you see? With a leading coefficient here, there's a 1 right there in the front. That's the leading coefficient. Leading coefficient is 1. Okay? What's the degree? The degree is the highest or the leading power. The degree is 2. I'm finished with that. That's done. Number 4. All right? This has to be factored. You have to factor this. Okay, now in this type of problem, it's a trinomial with 3 terms. See, 1, 2, 3. It's a trinomial. We have to factor it. There's a lot of powers and things going on here. So in this case, we did say, okay, to start a problem like this, here's what we're going to do. Watch this. All right, so I'm going to rewrite it very quickly. 7x cubed y to the 4th plus 21x cubed y plus 49 x cubed y cubed. Okay, here's what we're going to do. We're going to go down here, and I'm going to bring the plus sign straight down. I'm going to bring this plus sign straight down. I'm going to put parentheses around it. And then I'm going to go back and draw a division line under all three terms. I'm just trying to like get it set up. The sign straight down. There we go. Okay. All right. That's it. That's the shell of what we're about to do. All right. So first, we have to determine the greatest common factor, the greatest monomial factor. So look at the coefficients first. We do the coefficients first, then the variables. Coefficients first. What is the greatest monomial factor of each term? Well, I have a 7, I have a 21, I have a 49. What number is divisible by 7, 21, and 49? Obviously, the greatest monomial factor is 7. So we're going to go 7, 7, 7. All right. That's it for the coefficients. Now do each variable. And so now the variables, right? You want to look at all the variables and you want to find the least power that's in each variable. That's also the greatest common factor in each variable. And it's the variable that has the least amount. Okay, not the most, but the least. That's in all expressions. So here we have x power 3, x power 3, x power 3. So we know that each term 1 has an x. That's important. It has an x. And the least power in all three terms is x cubed, or x to the power 3. All right, so that's next. So we have x power 3, x power 3, x cubed. Okay. Do the same for y's. Make sure each term has a y, and you want to divide by the least power. Y to the 4th. Y to the power of 1. Y cubed, or power 3. What's the least amount? Good, y1. Y to the power of 1, or just y. So let's write that underneath. Let's just write that y. 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 Okay, once you do that, you're good. You're good. Because what's in our denominator, that is called the greatest monomial factor, and that's what goes in the front yard, if you will, of the parenthesis. Let's put that in the front. So 7 x cubed y goes in the front yard. That's out front. Got it. Now, simplify each term, and what you have left over is the answer that goes in these spots here. So 7 divides into itself one time. The x cubes cancel out. And y4 minus y1 gives me y cubed. 7 goes into itself one time. 7 going to 21 three times. The x cubes cancel out and the y's cancel out. So I just have a 3 right here. 7 going to itself once. 7 going to 49 7 times. The x cubes cancel out. And then 3 minus 1 is 2. So I have 7y squared. And that's it. It's factored. That's the answer. It's factored. Okay? If you got confused at any state or any of the process, stop the video, rewind it, look at it again, or go back to lesson 4.1, I think, or 4.2, no, 4.1, 4.2, 4.3. I think that's what it is, 4.3. All right. Over here, once again, we have to factor. Okay? And so in this case, first, always, whenever you're factoring, always look to see if you can't extract the greatest common factor. That's first. See if you can extract or factor out the greatest common factor. Okay? And in this case, the greatest common factor between 45 and 20, what's the greatest common factor between 45 and 20? Each number ends on a 0 and a 5, which lets us know it's automatically divisible by at least 5, right? So divide each term by 5, okay? So if I divide this by 5, I'm going to get 9. If I divide that by 5, I'm going to get 4. And since I'm dividing by 5, I have to multiply it by 5 to keep it the same. So in essence, you just factor out of 5. Factor out of 5 from each term. And that's what you get. This 5, put that in your back pocket. Don't forget it's in your back pocket. It's very important. Don't forget it's there. All right? Now, the 9. You know that 9 is a perfect square. 9 is 3 times 3. You know 4x squared is perfect. That is 2x times 2x. Let's put it all together now. All right? So put this 3 with this 2x. So I'm going to have 3 plus 2x. And then put this 3 with the remaining 2x, and that's going to be 3 minus 2x. Remember, one must be plus, one must be minus, because a squared minus b squared equals a plus b times a minus b. One must be plus, one must be minus. Doesn't matter which one comes first. No, never mind. Doesn't matter. And don't forget to bring the 5 down out your back pocket. Put the 5 back in front. And that's the answer. It's factored. Okay? That's it. All right. Number 6. Okay. Let's see what we have for number 6. 6, we have x to the negative 7. How do we rewrite x to the negative 7? Well, x to the negative 7 equals 1 over x to the power of 7. That's it. Because you know that this x to the negative 7 is really over 1. Everything is over 1. And we said when the exponent is negative, it's just a matter of taking the whole expression, either moving it to the numerator or to the denominator, either up or down, to make the sign of the exponent positive. And so that's what we did. We took this whole expression and we moved it down to the denominator. And moving it down to the denominator causes our exponent to become positive in essence. There's a lot more going on because, well, the rule states this, that b to the negative n equals 1 over b to the n. And this is really over 1. So that's really what happens. Just move it. And that's going to do it for number 6. Okay. Number 7. All right, 7. Seven is 5x plus 12 divided by 16x. Find all restrictions. What are the restrictions? 3 steps. Step 1, set your denominator equal to 0. 16x equals 0. Step 2, solve for x. Well, if 16x equals 0, divide both sides by 16, which means x equals 0. Because 0 divided by 16 is 0. Alright? Step 3, whatever you get right here, put the slash through it. Put the not equal sign through it. And there's your restriction right there. That's it. That's the restriction. X can be any number in the world. Any number. X can be from negative infinity to positive infinity. X can be any value except 0. Because 0 is what causes this denominator to be undefined. 0. So step 1, set the denominator equal to 0. Step 2, solve for x. Step 3, put the slash through it. And there's your restriction. Alright, that's it for that. Alright, number 8. Okay, what is number 8? Number 8, 3x minus 9. Is it a polynomial? Yes. Polynomial? Yes or no? Answer is yes, it is a polynomial. Yes. This is not a polynomial. If it were 3x to the square root of 5 minus 9, that's not a polynomial. If it were 3x to the 2/3 minus 9, that's not a polynomial, right? If it were 3x to the negative 7 minus 9. See, these are 3 examples, they are not polynomials. Because in order to be a polynomial, your power has to be a non-negative integer. Okay? To be a polynomial, it has to be a non-negative integer. Polynomial has to be a non-negative integer. Okay? Has to be a non-negative integer. So the power has to be non-negative. And it has to be an integer. Okay? Well, this is not an integer. This is not an integer. And this is not non-negative. That's why these are not polynomials. That's good. Alright. Number 9. And by the way, guys, I explicitly stated and made all of these points in your notes. Okay? So you can always, if you want to, you can always like go back and refer back to your notes. It's there. Alright, number 9. Simplify this expression. 4 to the power of 0. One. That's it. Alright, that's like saying, look, what is 3x to the power of 0? That's also what? 1. Don't get that confused with this one. Watch this. What is 3x to the 0? That is not 1. This right here represents 3 times x to the 0, which equals 3 times x to the 0. That's 1. So it's 3 times 1, which equals 3. You see the difference? The parentheses make the difference, doesn't it? It really does. All right, that's, oh, I'm sorry. This is number 9. That's number 9. All right, number 10. Okay, let's see here. 10. M cubed over 8 n cubed divided by 15 m squared over 2 n squared. Okay, what we have to recall here is that whenever you are dividing two ratios, when you have to divide the two ratios, you must always remember to multiply by the reciprocal of the latter ratio. Multiply by the reciprocal of the latter ratio. So I'm going to write the former ratio, which is 15m cubed over 8n cubed. I'm going to write that, but now I'm going to multiply by the reciprocal times the reciprocal, which is 2n squared over 15m squared. Okay, so now we're multiplying by the reciprocal, right? And now, for those who, if you can't see exactly how to cancel out these terms and how to reduce the terms, go ahead, I mean, you can write them out in prime factors if you want to, right? I mean, it's doing the most, but for some it's beneficial if you just write everything out. When I say write it out, here's what I mean. 15 is 3 times 5, right? And I have 3 m's here. 1, 2, 3. All over 8. And 8 is 2 times 2 times 2. And I have 3 n's. 1, 2, 3. Times, all right, I have a 2. And I have 2 n's. 1, 2. Over 15 is 3 times 5. And I have 2 m's. 1, 2. That is doing the absolute most, but it kind of helps you to see what we're doing and how things are going to cancel. And when we cancel, we always say it's the ratio of numerator cancels denominator. It's never a lateral cancel. You never cancel numerator to numerator or denominator to denominator. It's numerator cancels denominator. Up cancels bottom. Top cancels bottom, up cancels down. All right, so here we go. Let's start canceling some stuff out here. What goes? Notice this. I have a 3 up in my numerator, and I have a 3 in my denominator. I have a 5 in the numerator, a 5 in the denominator. I have a 2 in my numerator, I have a 2 in my denominator. You see how that's working? And let's keep on doing that. I have an m up top, m down low. Another m up top, another m down low. I have an n up top, n down low. N up top, n down low. And once you get to the point where there's nothing else to cancel out, whatever's left over, that's your answer. Let's see what's left over in our numerator. What's left up there? What's left? I have an m. That's all. What's left over in your denominator? Well, I have 2 times 2, which is 4. and I have an n. And I'm finished. I'm done. That's the answer. M divided by 4n. Okay? And that's number 10. And the answer on the sheet is D. D is the correct answer. It's D. All right, that's 10. Number 11. What do we have for number 11? 11. All right, 5q squared plus 27q plus 10. Factor it. Okay, let's factor this. All right. Well, it's a trinomial, it's 3 terms. Do we have a greatest common factor of the coefficients that we can take out other than 1? 5, 27, 10? No. There is no greatest common factor other than 1, so we're going to leave that alone, right? Okay, so in this case, this is that trinomial factoring, where we first have to write our binomials, and then we're going to put a 5q here and a 5q there. We need 2 numbers that multiply. Well, let me see. What's 5 times 10? Positive 5, positive 10. 5 times 10 is 50. Okay, so here's what we need. Here's what's needed. I need 2 numbers that multiplies to 50. And then those same 2 numbers have to add up to 27. You see how that worked? Check it out. I used each and every number up here. I used the 5, I used the 27, and the 10. I need 2 numbers that multiply to 5 times 50, or 5 times 10, which is 50. So I use these 2 numbers, 5 and 10, to give me the 50. And yet I need 2 numbers that add up to 27. What's in the middle? The product and the sum. Okay? Well, let's determine what these numbers are. Kind of obvious. You know that 25 times 2 is 50, and 25 plus 2 is 27. So put a positive 25 right here, and a positive 2 right there. We're almost done. Now look at each binomial. Look at this binomial, and then look at the other binomial, and see if there's a greatest common factor. Factor each binomial, and once you factor it, get rid of the factor. If you couldn't factor in the beginning, you can't factor in the end, right? What's the greatest common factor in our first binomial? 5 and 25. Factor out of what? A 5. What's the greatest common factor between 5q plus 2? Other than 1. There isn't any. So leave that alone. And get rid of this 5. If we didn't have a greatest common factor in the beginning, we can't have one at the end. Right? And there's your answer. It's factored. We're done. I think this is the most efficient way to factor whenever you have a lead coefficient in a trinomial that's greater than 1. That's 5. It's greater than 1. Do it this way, you'll be okay. All right, that's number 11. Number 12. Where's my eraser? Oh, here it is. Okay, what is number 12? Multiply. We have y being multiplied by negative 2xy minus 7x minus 8. Multiply it. Well, here we go. First, multiply y times negative 2xy. Well, that's going to give me negative 2xy squared. Because the power of y is 1, the power of y is 1. And last I checked, 1 plus 1 is 2. You add the powers. Alright, and then you take y to the power of 1 times a minus 7x. That's going to give me a minus 7xy. And then we take y times minus 8. That's going to give me a minus 8y. That's done. Nothing left to do. That's the answer. All right. 13. Okay. What's 13? Flip the page. Alright, now 13 is very similar to number 1. Because some of these problems, they repeat themselves. 1 is like 13. Okay, 13 is just like a number 1. So now we get into that whole repeat kind of a thing here. So 13 is a squared b cubed over ab, and this quantity is cubed. Simplify. Ladies and gentlemen, there's no set way of doing this. You can work on the inside and then work your way out, or you can start on the outside and work your way in. Either way is correct. It does not matter. Whichever one you're most comfortable with, that's the way you can go ahead and do it. What I'm going to do, I know my power is 1 here. I'm going to start on the outside and work my way in. So I'm going to take 3 and multiply it first times 2. That's going to give me a power 6. And then 3 times 3, which is b to the 9th, over 3 times 1, a cubed, and then 3 times 1 is b cubed. So I multiply first, and then I'm going to see if I can add anything. There's nothing there to add, numerator, denominator. There are no terms up here to add. You can't add none of the coefficients, or none of the powers here. So now I'm going to go ahead and subtract. Alright, so subtraction is 6 minus 3. That's a cubed. And then 9 minus 3 is 6. That's a wrap. Okay? So in essence we said a to the power of 6 minus 3, and then b to the power of 9 minus 3. 6 minus 3 is 3, and 9 minus 3 is 6. Okay? That's what we did. So that was done. Alright, that's number 13. 14. $14. 25 x cubed plus 60x plus 36 equals 0. Okay, now 14, ladies and gentlemen, and what do they want us to do? Let's see, 14, they want us to factor it and solve it. Alright, so the instructions for this one, they want us to factor and solve. Please notice that 14 is very similar to number 11. Okay? You see how I factored number 11? We have to factor 14 now. Alright? The only difference is, right, notice this. In number 11, 5q squared, this is what? Not a perfect square. And number 10 is not a perfect square. See, the first and last terms are not perfect squares. However, in this case, 25x squared is a perfect square. It's perfect. And what makes it perfect is because 25x squared is 5x squared. 36 is perfect. And what makes it perfect? Well, because it is 6 times 6, which is 6 squared. So our first and last term are perfect squares, which makes the factoring so much easier now. So when I factor this, the factors are going to be 5x, keep the first sign, plus 6, quantity squared. That's it. That's the factors. So I have 5x plus 6 twice. So in essence, I have 5x plus 6 one time and 5x plus 6 two times. Okay? There you go, it's a perfect square. And so basically, the 5x squared, this right here, this 5x is like the root of it. And right here, 36, this 6 is like the root of it. And so now let's solve each of these. Well, you don't have to solve both of them, just solve. So here's the factors right here. It's factored. Now you got to solve it. Just solve one of them, because you'll get the same answer twice. So when we solve it, it's going to be 5x plus 6 equals 0. Subtract 6 from both sides. So 5x equals negative 6. Divide both sides by 5. So x equals negative 6 over 5. There you go. That's it. So here's it factored, here's it solved, that one's done. But you have to look for those perfect squares. Whenever you have perfect squares, that makes it so much easier. If the first term is perfect and the last term is perfect, then go directly to the root of it and you'll be all right. That's the key, right? It's just like if I had, I don't know, what if I had 36. If I had like 100 y squared, and on the other end I had maybe plus 16, right? Well, let's not go 16, let's go 49. Plus 49, I know the root of this, since this is already perfect, the root of it is 10y. And the root of this, since it's perfect, is 7. And then that's what I would use right here, 10y and 7. All right, that's 14. 15. Okay. We have d squared plus 6d plus 5d plus 30. What do they want you? Completely factor by grouping. They want you to use the grouping method to factor this. Okay? The grouping method. Well, this is not too bad to factor by grouping. Because what we want to do, we want to group factors, or we want to group terms that have common factors. Group the terms that have things in common, right? For example, I can group the first two terms because they both have a D in common. And then I can group the last two terms because they both have a 5 in common, right? So here we go. So for the first term, they have a D in common. So take out the D, and I'm going to be left with D plus 6. All right, plus, take out a 5 from the second group. And I'm going to be left with D plus 6. You see that? Now you want to put the blue with the blue, and you want to put the black with the black. Keep the blue together, keep the black together. So the blue is D plus 5, and the black is D plus 6, and there you go. There's your answer. Keep the blue, keep the black together, and that's a wrap. That was done. Okay? That's grouping, factoring by grouping. Alright, 15 is done. Let's get to problem number 16. Okay. Alright, 16. We have 6x squared minus 8x minus 2x squared minus 2x. Okay, with this problem, many ways to approach it, many ways to solve it. I think the most convenient way for me is first you always write your first polynomial first. The initial thing you want to do is just rewrite the initial polynomial without parentheses. Let's do that. So let's write this polynomial without the parentheses. 6x squared minus 8x minus 3. Everybody good? You got it? Okay. Now, notice this. We have a minus sign here. Minus this polynomial. Quantity 2x squared minus 2x. Okay? So since there's a minus sign, you have to distribute the minus sign, which is going to cause everything in this polynomial to be opposite what it is. So here's what I suggest that students do. Right? Take your paper and cover up everything, even the minus sign. Cover the minus sign up. And everything inside this parenthesis, make it opposite. Right? We have a positive 2x squared, it becomes a negative 2x squared. We have a negative 2x, that becomes positive 2x. You see that? I made everything in the parenthesis opposite. Why? Because I had a minus sign out here in the front. There was a minus sign out there knocking on the front door. And when you let something negative in your house, it changes everything. Right? So this negative out here was knocking on the door. We let it in. And when it walked in, it changed the sign of everything inside the house. So the positive 2x squared becomes negative, and the minus 2x becomes positive. All right. So now that that's done, we can combine like terms. So I have a positive 2x squared and a negative 2x squared. That's going to give me a positive 4x squared. And then I have a negative 8x and a positive 2x, which is a negative 6x. And bring down this minus 3. And there's the answer. And that's it for number 16. 16 is done. Last page. Yay! Okay. Now on this last page, I think I want to erase all the board and use more board for these last couple problems. All right? So let's see here. For number 17, I'm going to use these two sides here. So I'm going to use all of this now for number 17. 17. We have 4 over x minus 6 plus negative 6x plus 20 divided by x squared minus 8x plus 12. All right. So now we have to add and or subtract these rational expressions now. Let's do that. No problem. So the first thing we want to do is make sure we have all of our denominators factored. Okay, this is lesson 5.2, I think. 5.2. Make sure you have all your denominators factored. Let's do that. So we're going to have 4 over x minus 6 plus negative 6x plus 20 over. Notice I said have all your denominators factored. Numerator, don't worry about it. Factor your denominator right now. That's first. Factor your denominator. Factor the denominator. All right. So how do we factor x squared minus 8x plus 12? Let's factor that. Well, the factors are going to be, I need two numbers that multiply to 12, and they're going to add up to negative 8. Because there's a 1 right there. 1 times 12 is 12, and the negative 8 goes there. It's just like the last problem we did, I think number 11. Same ideology, same mindset, number 11. What are those two numbers? How about, let me see, negative 6 and 2, that's, well, no, negative 2, how about that? Yeah, because a negative times a negative is a positive. Negative 6 times negative 2, and then negative 6 plus negative 2, there we go. So I want to use a negative 6 and a negative 2. So that's going to give me x minus 6 times x minus 2. Okay, good. So that's step 1. We kind of simplified or factored our denominators. Now we need to construct or find the least common denominator and use that to produce what we call equivalent fractions. We need equivalent fractions now, right? Okay. Two fractions that are equivalent. So give me something that looks like this that's equivalent to this. It's equivalent fractional component. Well, it would look like, okay, here we go. So we would have 4 over x minus 6, right? And multiply top by x minus 2 and bottom by x minus 2. Okay? It's like I multiplied it times 1. See, these fractions here, this fraction and this fraction, they are equivalent fractions, right? Plus negative 6x plus 20 over, all right, x minus 6 times x minus 2. And so what happens is that this equivalent fraction right here, it also gives us our least common denominator. All right. And so the next step is for us to combine the numerators. So combine the numerators. So leave the denominator alone. That's going to be x minus 6 times x minus 2. That's fine. Leave that alone. work up in the numerator. So I got to take 4 times x, which is going to give me 4x, and then 4 times a negative 2, which is going to give us minus 8, then a minus 6x, and a plus 20. Combine like terms in the numerator. I have 4x and a minus 6x. That's going to give me a minus 2x. And negative 8 plus 20, that's going to give me plus 12 all over x minus 6 times x minus 2, which is going to equal. Now, since our denominator is already factored, now we look to factor our numerator. Okay, let's factor our numerator. Bop, 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 bop. From the numerator, you can factor out a negative 2. Take out a negative 2, so it's going to be negative 2 times x minus 6, all divided by x minus 6 times x minus 2. And at this stage, I notice that my x minus 6's cancel out. One's on top, one's on the bottom. And so my answer is going to be negative 2 over x minus 2. Which is C on your review sheet. It's C. C is the answer. All right, that's 17. 18. Number 18. We have x squared minus 2x minus 24. All right, there's a 1, of course, right here. All right, so if I multiply, let me move this over, 18 there. If I multiply 1 times negative 24, that equals negative 24. So I need two numbers that multiply to negative 24. Because I use 1, I use negative 24, and yet they add up to give me what's in the middle, negative 2. What are those two numbers? That multiply to negative 24, and yet their sum is negative 2. Product, negative 24, sum is negative 2. What is it? X here, x there, because x times x is x squared. So what are those two numbers? What can we fill in there? What goes there? Well, let's see here. Let's go maybe 6 and 4. Let me see, negative 6 and a positive 4 is negative 24, and a negative 6 plus a positive 4 is negative 2, so that's going to do it. Negative 6 goes right here, and plus 4 goes right there. You could have written it the other way around, doesn't matter. Okay? You could have said x plus 4 first, and then x minus 6 second. It doesn't matter. Both of them are still correct. Okay? All right, that's number 18. Okay. Number 18. And then let's do 19. Well, let me see. 19, I'm going to hold off on 19. I'm going to do 19 last. Let's just do the last problem right now. Let's do number 20. Then I'll come back and do 19. Because there's something I want to show you about number 19. Something in particular. All right, so let's do number 20 right now. Okay, here we go, 20. we have 9x plus 1 minus negative 9x plus 2. We just did one like this. Is it still up here? No, I erased it. What number was that? We just did one like this. It was number 16. Just like 16. Okay? So, rewrite the first polynomial without parentheses. It's going to be 9x plus 1. And then take your paper. There's a minus sign right here. Cover it all up. Cover it all up like that. See how I covered it all up? Right? And take what's on the inside and make it all opposite. Because that minus sign makes everything inside opposite. So that's going to give me a positive 9x. Right? And a negative 2. Minus 2. Combine like terms. Positive 9x is a positive 18x. And 1 minus 2, be careful with that. That's 1 minus 2. Don't tell me 1 minus 2 is 1. It's not. It's negative 1. There's the answer. That's number 19. I mean number 20. Okay, now let's get back to number 19. All right. All right. Last one, number 19. All right, so we know that a cubed minus b cubed equals, well, no. I don't want to start with that. Let me write the problem out first. Let me write the problem. Number 19. We have 27 x cubed plus 8 y cubed. And the answers are A, it could be 3x plus 2y times 9x squared plus 12xy plus 4y squared. It could be B, and B is 3x squared plus 2y times 9x squared minus 6xy plus 4y squared. It could be C, and C is 3x plus 2y times 9x squared minus 6xy plus 4y squared. Or it could be D, and D is 3x minus 2y times 9x squared plus 6xy plus 4y squared. Okay, so here's the question. They want you to factor this. Here are your possible answers, and here are the formulas. The formula says that a squared, or cubed, cubed. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. All right, those are your formulas there. Now, let's do the problem. Let's approach the problem. Here we go. 27 x cubed plus 8y cubed, let's factor it. Okay? So first thing you have to do is determine the formula you have to use. Is it the first formula or the second formula? Is it the sum that's between two cubes, or is it the difference that's between two cubes? Okay? This is the sum between two cubes. Okay? So we have to use a cubed plus b cubed equaling a plus b times a squared minus ab plus b squared. Okay, so we have to use that algorithm. That. So we know which one we have to use. We're using the first one. Check, check. All right. Now let's go and work on each factor. I need the cube root, the root of each factor. So I'm going to have to write it as such. Parenthesis, cubed, plus, parenthesis, cubed. What goes inside here? What is the cube root of 27 and the cube root of x? 3x. Because 3 cubed is 27 and x cubed is x cubed. How about 8? What's the cube root of 8? And the cube root of y cubed? 2y. Because 2 cubed is 8 and y cubed is y cubed. Okay? So here's what it means. It means that this here, this 3x, that is your a. And this 2y, that is your b for this over here. So now you know what a is, you know what b is. All right? So the formula states that this is going to equal, here we go, it's going to equal a plus b times a squared minus ab plus b squared. And you know what a and b are right now. So we're going to have, well, what is a? A is 3x. 3x. Plus, what is b? B is 2y. Times a squared. What is a? 3x. 3x squared. That's important. It's the whole 3x. Quantity squared. It's not 3x squared. Don't write it like this. Don't say 3x squared. Incorrect. Wrong, 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 wrong. Wrong. It's this. It's 3x quantity squared. Because a is all of it. All right. Minus 3x times b, which is 2y. Plus b, which is 2y. Same as we did with 3x. 2y quantity squared. Okay, now we simplify. Let's simplify it. So we're going to have 3x plus 2y times, this is going to give me 3x squared is 9x squared, minus 3 times 2 is 6xy, plus 2y quantity squared is 4y squared. Okay, this is the answer. Which one is it? A, B, C, or D? It is C. So C is the correct answer. C is the correct answer. Now I know some of you guys are saying, Mr. Wright, wow, that was a lot. That was a long problem. That was a lot. That was a lot of work. I know it was. But I want you to watch this. Follow me on this. What if you used your answers? This is a testing strategy, a testing technique. When they give you the answers, use your answers to determine the correct answer. They give you the answers, use them. Here's how we're going to use it. Watch this. Let me pick up my pointer here. All right. So now we're going to find the answer without using no marker. How about that? All right. So here's the problem. 27x cubed plus 8y cubed. First, you have to determine which formula you're going to use. That was pretty easy. We used the first one, right? Okay, good. Which means if I use the first one, please notice the pattern of the factoring. It's just a plus b. And this a plus b, there are no squares in here. The squares are over here, right? But in this first term right here, a plus b, there are no squares. It's just a plus b, okay? No squares. Let's go to our answers. This one doesn't have a square. See, 3x plus 2y, no squares. This one does have a square. See the x squared? So we know that b cannot be the answer because the first binomial has a square in it. There are no squares here. The squares are in the trinomial part, not the binomial part. So we know that b cannot be the answer. B is eliminated. Furthermore, since we're using formula number 1, notice this sign right here has to be plus. If this is plus, then the first sign has to be plus. If this is minus, then the first sign has to be minus. Here's a plus, sum, so the first sign has to be plus. Which means I can get rid of d, because this first sign is minus. So d has to go. See, we're using our answers to try to determine what the correct answer is. We're using these selections to get to our correct answer. Okay? And what else did we notice here? Look at the pattern. If this is a plus, the first sign is plus. And then we go minus plus. So it goes plus, minus, plus. Well, look at A. A goes plus, plus, plus. This pattern is plus, minus, plus. This is plus, plus, plus. This is also a no-go. So in actuality, you could have selected the correct answer to this problem without writing one thing, without doing no work. Look, determine which algorithm, which formula you're going to use. Look at the pattern in the formula and look at the signs. Look at the signs. Okay, look at the signs and look at the powers. Signs, plus, minus, plus, and look at the powers. Power 2, power 1, 1, 1, 1. And that's it. So whenever you have a multiple choice test, always use your answers to kind of help you along the way. Okay? All right, that's it. That's the review. So do well on test 3. And whatever you do, stay positive and it'll always work in your favor. If you stay positive and study, work the problems out, work really hard. Practice makes what? Exactly. Practice makes better. Keep practicing, keep working on it, and you should do all right. If you have any questions, be sure and send me a text or an email, reach out to me, and I will reach back out to you. Okay, thanks for listening. Thanks for giving me some of your attention and some of your time, and stay positive.